Hello and welcome to our project presentation. We are Team SheCodes and our team members are Pakalina, Konisbekova-Yenglik, and Bakieva Isuliu. Together, we have combined our strengths in machine learning, front-end development, and data management to create a system that not only predicts diabetes risk but also provides patients with personalized support. Let us begin with the problem. Type 2 diabetes T2D is one of the world's fastest growing health challenges. According to the IDF Diabetes Atlas 2025, around 589 million adults worldwide were living with diabetes in 2024, and this number is expected to rise to 853 million by 2050. In 2024 alone, diabetes caused over 3.4 million deaths and generated more than $1 trillion in health expenditures. Alarmingly, about 43% of people with diabetes remain undiagnosed, leaving them vulnerable to serious complications like cardiovascular disease, kidney failure, retinopathy, and diabetic foot ulcers. To address this, researchers and clinicians have been exploring the concept of a digital twin, a virtual representation of a patient that can simulate disease progression, predict risks, and support decision-making. However, most existing solutions are unimodal, meaning they rely on only one type of data, such as lab results or wearable sensors. This limits accuracy and fails to capture the complexity of the disease. That's why we chose to build a multimodal digital twin for T2D by integrating multiple data, sources, clinical records, survey data, and medical images. We achieve several key advantages. First, early complication detection. Retinal and foot ulcer images allow us to detect issues before they become severe. Second, improved predictive accuracy. Combining EHR, survey, and imaging data performs better than using one data type alone. Third, personalization at scale. Digital twins can simulate individual disease, progression, and intervention scenarios. And finally, sustained patient engagement. With the help of a conversational AI assistant, we transform passive monitoring into active health coaching. This is why we chose a multimodal approach. It is more comprehensive, accurate, and impactful for both patients and clinicians. Now let's move to how we built it. Our project combines 4 datasets, each processed with models suited for its type. With Mimic Chao, we use hospital EHR data, lab results, diagnoses, and procedures. After cleaning and pre-processing, we apply a logistic regression model, which is interpretable and effective for predicting diabetes from structured clinical data. With NHANES, which contains U.S. population survey and lab data such as BMI, blood pressure, glucose, and HbA1c, we compared logistic regression, decision trees, and random forest. The random forest performed best, so we use it for population-level diabetes risk prediction. For complications, we rely on imaging datasets. In diabetic retinopathy detection, we trained an efficient net B3 model on thousands of retinal images, classifying severity stages from no DR up to proliferative DR. For diabetic foot ulcer detection, we again use EfficientNet B3, trained to distinguish between healthy skin, normal wounds, and diabetic ulcers. Together, these 4 pipelines create a multimodal system. Mimic-IVIS and NHANES models predict diabetes onset from structured data, while DR and DFU models detect complications from images. Integrated, they form the backbone of our digital twin. Now let's see how this comes together in the website. The main page introduces users to T2D and the goals of our project. The interface follows a dark theme, with pink highlights to emphasize keywords and keep the design visually engaging and easy to read. The website is built with Flutter, which makes it responsive across devices, and all data is stored securely in Supabase, our cloud database. After logging in or signing up, users land on the dashboard, where they can explore different modules. In the NHANES module, users input demographic and health information such as age, BMI, blood pressure, and glucose. With one click, the system predicts their risk of diabetes and categorizes it as low, borderline, or high. In the Mimic Chopper module, users enter hospital lab results such as HbA1c and cholesterol and instantly receive a clinical risk prediction. In the retinopathy section, users upload a retina photo. The AI analyzes it and classifies the severity of diabetic retinopathy, helping to detect vision problems early. In the foot ulcer section, users upload a photo of their foot, and the system detects whether there are wounds or ulcers. The that may need medical attention. But we go beyond risk prediction. Our Gemini AI assistant acts as a digital health coach. It generates personalized meal plans, tailored exercise programs, weekly progress reports, lifestyle tips, and even educational quizzes. All of these are displayed as interactive cards in the interface, making it easy for patients to follow and stay engaged. Importantly, all predictions and recommendations are stored securely in Supabase, so users can review their history and track progress over time. In conclusion, our website is more than just a diabetes tracker. It combines structured data, imaging, and AI coaching into one multimodal digital twin, built with Flutter and powered by Supabase. It predicts risks, detects complications, and supports patients with personalized guidance, offering a proactive and user-friendly approach to diabetes care.